Sup guys, welcome back. So today I'm going to do a video on scatter plots and the correlation coefficient. Okay, so let's start by looking at actually what a scatter plot is. So a scatter plot is just a type of graph that displays the relationship between two variables. Each point on the graph represents a pair of values for those two variables being plotted. So here you can see the example I've given is test scores and the number of hours studied. So this person here, for example, studied about 4 hours and got a test result of, let's say, 28. So we're just plotting those on a graph here and seeing if there's a relationship. Now, a scatter plot is useful because it obviously lets us visualize what we're looking at, but also to see if there's any trends. Now, when we talk about correlation just is a way of saying how strong is the relationship between those two variables. So on this side, we've got a perfect positive correlation. So if they're all in a straight line, it's perfect positive. Now you can kind of think the positive and negative aspect of it is just gradient. So it's the same kind of idea. So that's a positive gradient. So in this case, it's perfect positive correlation. Now, as we move along, as the dots get more scattered and less in a straight line, we move to highly positive, or also known as strong positive correlation. Then we have low positive. Okay, so this is also known as weak. Now, on the other side, negative is the same kind of idea. So here you've got negative, perfect. This is strong, negative, weak, negative, and so on. And then also here you've got no correlation. So you might have two variables which have absolutely no relationship whatsoever in terms of the data they actually represent. Okay, now I also want to talk about one aspect is correlation doesn't imply causation. So I'm sure you've heard of this before, but basically what it means is just because things correlate doesn't mean that they actually are caused by one another. So in this case, you can see we've got high school graduates and pizza consumption. So just because they correlate doesn't mean that one is caused by the other, because clearly, well, you'd assume that because there's more high school graduates, that shouldn't cause more eating of pizza necessarily. Okay, so just be careful there. Okay, now we're going to talk about how to actually define or actually quantify correlation. So in this course, we're going to actually use what's known as the Pearson's correlation coefficient, which is actually given by letter R, and it just represents the relationship as a number. So the correlation coefficient ranges from -1 to 1. So we're going from perfect negative to perfect positive, okay? And everywhere along the way it gets weaker and weaker up until no correlation in the negative direction, and then moves to a more positive direction. Okay, so from moving on here, we'll use this language going forward. So strong, moderate, weak in the negative, and likewise weak, moderate, strong in the positive. Okay, let's look at this quick exercise here. It says match the following graphs to the correlation coefficients below. So the first one on the left here is clearly going to be a perfect negative because they're all in a straight line. So we're going to have -1 here. So R is equal to -1. Now this next one here, right, it looks like it's in a negative direction, and you can kind of see pretty clearly that it moves in that kind of format. So of all the options we've got here, let me cross out -1. We're looking at either -0.5, -0.9, -0.2. So I think that's actually relatively strong. Let's just scan to see if we have any stronger negative ones. So this one here kind of jumps out to me. It's kind of in a negative direction. And the dots, I would say, are much closer than this one here. So I'm actually going to assign this one here to be -0.9. And then this one can be -0.5. Cross those out there. Now, which other ones are kind of in the negative direction? So I think this one here, you can kind of see the dots moving lower, the majority of the dots moving lower. So I think that one there is going to have a correlation coefficient of -0.2. So in the negative, but pretty weak. Okay, let's start with the next obvious one. So on the bottom right, we've got a perfect positive. So that's +1 here. Cross that out. On this one on the very left, the bottom left, that's pretty strong in the positive direction. So which other ones do we have to work with? We've got 0.8 and 0.7. So I think this one is pretty strong. This one is also moving in the positive direction, but is less strong, so a bit more weak. So I'm going to go with 0.8 here. and 0.7 there. And I've just got 2 to go. So out of these ones, which one would be 0? I think this one, you can kind of see it moves in a positive direction. So in general, the dots are moving upward, but slightly. Whereas this one, it just seems all the dots are kind of just randomly spread out. So I'm going to assign this one as 0 and this one as 0.3. All right, cool. Thanks for watching this video. If you enjoyed it, give me a like. Otherwise, I'll see you in the next one. Peace.